discussion on democratizing ocean observation through low-cost technology. Let me offer you a few words of introduction. Building on existing initiatives and past successes, the AtlantOS program aims to advance sustained ocean observations at the Atlantic Basin scale, actively supporting collaborative partnerships between observing networks, data and information systems, and the wider user communities. The recurring AtlantOS Ocean Hour webinar series, which returns today after a short summer break, is scheduled to take place every other month. This event is an opportunity for the community engagement as we develop the All-Atlantic Ocean Observing System. I am Lucie Cocampo from IFREMER, the French Research Institution for Exploitation of the Sea. My work focuses on the design of observing systems with a special attention to sustainable and inclusive approaches. As a member of the steering committee of AtlantOS, I have the chance to moderate this Ocean Hour today with Mariana. Mariana, thank you for organizing this event, and I hand over to you for an introduction.
Hi, everybody. I'm Mariana Rocha de Souza. I'm Brazilian, as some of the speakers here too. And I am right now a Canals Fellow placed at GEOMAR at NOAA OER, and my portfolio is the Argo program and the AtlantOS. So that's why I'm here. Welcome.
Thanks, Mariana. So today's AtlantOS Ocean Hour will focus on low-cost technologies. The emergence of inexpensive, efficient, and sometimes creative ways to collect ocean data has catalyzed a vibrant, user-driven community that enables the development of citizen science programs and do-it-yourself projects. These oceanographic tools support the goals of the United Nations Decade of Marine Sciences for Sustainable Development, which aim to encourage a more inclusive and participatory approach to oceanography, better forecast of ocean phenomena, and democratize access to the ocean. Our four speakers will present some of the projects they've been involved in four short presentations of 7 minutes, followed by a 30-minute panel discussion. And if you have the time after this hour, I strongly encourage you to go and check our networking event using WonderMe, and Mariana will provide details at the end of the panel discussion. This session will be recorded, and please keep your microphone muted. And if you feel like asking a question, please use the chat and raise your hand at the end of the 4 presentations. Mariana will keep track of the time, and I think I've already talked too much. So without no further delay, let me introduce you our first speaker. Dr. Robert Brewin is a senior lecturer at the senior lecturer in physical geography at the University of Exeter, UK, and UKRI Future Leader Fellow. He's a satellite oceanographer with a keen interest in phytoplankton, optics, and citizen science. And he's also a surfer for many years. His presentations will be on expanding ocean observations using recreation and low-cost technologies. Robert, the floor is yours.
Can you all see my screen okay? Great. Okay, I've got 7 minutes, so I'm going to dive straight into it. I haven't got too much time. I just want to make the point on this first slide that some of the work I'm presenting has been a real team effort with colleagues from all around the world, from various international institutes. And I've just popped their photos up on the slide there. Okay, so firstly, what I want to do is I want to put the talk in a little bit of context and really talk about one of the big challenges we have with ocean observations. We know how important the oceans are in the climate in the Earth system as a whole. They've absorbed around 25% of anthropogenically emitted carbon dioxide, around 93% of the excess heat from global warming has gone into the oceans. And in order to understand how our planet's changing, we need to monitor the oceans and so we can make robust predictions for how our planet's changing in the future. So we require accurate observations of the ocean for ocean management. And yet, despite this, there are many regions of our ocean that are critically undersampled. And I'm just going to show 2 examples here. One on the left is very near shore environments, which are difficult to deploy conventional oceanographic equipment. They're very dynamic. They also need to be sampled potentially at a much higher temporal and spatial frequency because they're so dynamic. Another region, and Priscilla, you might recognize this. This is from AMT 23, a photo of the North Atlantic gyre. And I'm talking about oligotrophic regions here, which constitute around 70% of the ocean's surface. They are critically undersampled due primarily to the fact that they're quite hard to access. So that's one of the challenges we need to address. But we also have opportunities, and that's what we're talking about here today in this workshop. One of the opportunities is low-cost technology. And there's really been a revolution over the last couple of decades in low-cost technology, development of Raspberry Pis, Arduinos, mobile phone-based sensors, also in computer-aided manufacture as well, with, for instance, things like 3D printers. So a lot of environmental sensors are becoming smaller, cheaper, and more accurate, and this is allowing us to integrate them into new platforms to help address this big challenge we have. Another opportunity we have, talking about platforms, is looking for new platforms. And this is some work we published back in 2017, just showing the number of surfing and diving sites around the world. We can see that surfers and divers regularly go in and out the ocean along the majority of the world's coastlines, certainly in low to mid latitudes. And there's a lot of potential to integrate these low-cost tech into recreational water sports equipment to improve sampling, at least in the nearshore regions, which we know are critically undersampled. Another example here from a paper in 2014 by Loro, which shows the monthly sailing yacht tracks around the world. And we can see that these sailing yachts are regularly going into some of those inaccessible oligotrophic regions I touched on in the second slide. So there's potential to tap into these marine recreational water sports to collect ocean observations. And now there's another potential benefit with engaging outdoor recreational enthusiasts and promoting outdoor recreation. And this is, I'm talking about this really in the context of this extinction of experience theme. So this is this idea that humans are interacting less and less with nature as time passes, particularly in the younger generations. You can think, for instance, how often people spend their time on phones, on computers, children gaming, things like that. Now, we know from past research that there is a strong link between outdoor recreation, connection with nature, and as a consequence, promoting environmental concern and changing, promoting pro-environmental behavior. Just to highlight also the importance of getting children or the young generations to connect with their nature through childhood nature experiences, outdoor recreation, as this can have a significant impact on their pro-environmental behaviors when they become adults. Okay, so in the context of the challenges and the opportunities I've just discussed, I'm just going to briefly touch on a couple of projects that we've been running. The first one started back in 2014, and it was the idea of integrating low-cost sensors into surfing equipment. So in this example, we attached a temperature sensor to the surfboard leash and had a GPS device when we went surfing, and collected a year's worth of temperature and location data, which we demonstrated is useful for environmental monitoring. Now, around the time, there was a group in the US who integrated an environmental sensor package into a surfboard fin, which we began collaborating with. And they subsequently distributed these fins to a range of surfers at specific locations around the world to collect a large data set. And we've been doing a lot of work demonstrating the applications of this data set. This example here is just from some work we published earlier this year, where we use these observations to validate high-resolution satellite Landsat 8 sea surface temperature products, and also determine the best satellite processor for monitoring nearshore temperatures. We've also been looking at integrating other sensors into surfing equipment. This is just an example from a master's student I had, where we collected some data on phytoplankton when we went surfing and demonstrated some interesting features in the summer between phytoplankton at the beach and phytoplankton a few miles offshore. So the final project I'm just going to touch on here is another project where we've designed and developed this miniature Secchi disk. So for those of you who may not be aware, Secchi disk is a small white disk you lower into the water, and the depth at which it disappears from sight is proportional to the clarity of the water. You can also look at the color of the disk at about half the Secchi depth, and the color tells you something about the type of material in the water. And these techniques are over 150 years old. All we've done here is just integrate it into a smaller package, which we 3D printed. And we distributed these devices to around 100 recreational citizens. Okay, I'm just finishing up. Around Lake Vemurban in India to map the clarity and the color of the lake. And just finally, a nice example of how these devices can help empower citizens. In this example, a couple of buildings were illegally built on the side of the lake and had to be demolished. And when they were demolished, a lot of material went into the lake, and the citizens monitored the clarity and the color of the lake for the consecutive weeks after demolition and demonstrated that it took about 5 weeks to go back to pre-demolition conditions, giving some information on how the lake flushes. And we're also carrying on a lot of this work within the EU Monocle project and a new project in the US we have with the Gordon and Betty Moore Foundation. So I'll stop there and pass on to the next speaker.
Thank you very much, Robert. I know it's frustrating, only 7 minutes, but we'll get the opportunity to discuss later on. So let's move on with our second presentation. Our second speaker is Priscilla Lange. She's a professor of oceanography at the Federal University of Rio de Janeiro, Brazil, and she shares with Robert's interest on satellite data and phytoplankton. This summer, Priscilla helped develop the monitoring of harmful algal bloom, HAB, in Rio de Janeiro, Brazil, using remote sensing and citizen science, as the monitoring involved collection with Polynesian canoe sports clubs, collection on beaches and sailboats. Priscilla, the floor is yours.
Okay, now you can hear me. Thank you for the introduction, and thank you for the invitation to speak here. It's a great pleasure, and I'm quite new in the citizen science field, so this is maybe my first work with this. It's very exciting. So we've been trying to monitor algal blooms here in Rio, and it's a combined effort of myself, Professor Gleice Moser, and Professor Silvia Nascimento, both from here in Rio, and there's a lot of collaboration as well from other institutes and other people. I'll talk later. So this is an image of an algal bloom we had here last summer, and you can see green water and some red foam in there. And this is Copacabana, the famous beach here. So let's move on. So an algal bloom, a harmful algal bloom, is an algal bloom that causes any damage to human health or the environment, or both. And usually these blooms, the cells are so concentrated, the phytoplankton is so concentrated in the water that it changes the color of the water and leads to some water discoloration. So here you can see another image of a bloom that was actually two blooms. You can see some green water on the top and red water in the bottom. And the color of the water is something that can be detected by people, right? So we can detect and interpret this. So why not use people as sentinels of harmful algal blooms? So we've been trying to do this here in Rio. And we've been trying to do this because in the last summer we had major events here. So usually to monitor harmful algal blooms, we need to first detect the bloom, and we use the color of the water to do this. And we can both use our own eyes and also satellite images to do this. After doing this, we have to go there, take water samples, and actually analyze what's in the water to know if it's toxic or not, or potentially harmful to the environment. And then once we have this diagnostic of the bloom, we can lead to some mitigation actions. So decision-making comes from this information. So it's a very important process to detect these blooms. And we can actually use citizen science to both detect the blooms visually and also to collect samples. So in the last summer, it was very useful for us here in Rio, and it was all that we had. So citizen science was not an option. It was all that we had because we had no funds, especially after the pandemic. So the last summer was anomalous here. We had the largest red tide ever observed here. And we actually had a cascade of several blooms of several colors here in Rio because we had many heat waves. So this is a satellite image of the largest red tide we had. And then what happened was that people started sending pictures, and these pictures were circulating on WhatsApp mainly, and it got to us. And I was playing beach handball by then, and I observed that the color of the water was very strange. So I started taking samples. I borrowed a microscope and I started looking at the water, and I saw that everything was very strange. And we got a lot of help from really random people. Some of them I don't know who they are. And this is an image of a bloom that was observed here in Rio. We got these via WhatsApp from a friend that was on vacation. So there were red blooms, green blooms, and we asked her to take samples for us, and then we could actually analyze what was in the water. So that was precious because it was the only diagnostics we had from the bloom. And we could also go to assess satellite images and have an idea of the extension of the bloom and where it was. And I started posting these images on social media, and a lot of people started reaching out and sending more information about new blooms. So we established a system by accident that worked really well to detect blooms using social media. So these are just examples of videos that we received from different types of blooms. So we could go there, take samples, and analyze what was in the water. So it was really very, very impressive. So the idea is to make this more systematic, create a phone app where people can submit more information about the blooms, about what they are observing in the environment, and also send images and videos using this app and the location of the observations. And we don't have the app yet, but we do have a social media, an Instagram account that if you have any information about blooms in Rio, you can send to this Instagram account, please. It's really, really helpful. And it got to people practicing water sports here in Rio too. So over the summer, it was over 3 or 4 months, we started getting in touch with these groups, especially the Polynesian canoe people. And they actually got to take samples for us of several blooms, especially engaged to the people from the State University of Rio. And here there are some images of people in Polynesian canoe and stand-up paddle boards taking net tows of plankton for us. And we could also use these images that we got and information to go to the right spots on the right time and take samples on the beaches. And these are the only samples we have from these blooms. We don't have anything else. So this is really, really precious and useful. And this is one example of how we're using it. So we can actually detect some of these blooms using satellite imagery, but we have to confirm that this is actually a bloom and not something else that has the same color. So we use these samples to confirm, and in the last summer we could confirm that it was, in this case, Mesodinium, and we could use the same model to track these blooms over time and go to the past. And we can see in this top plot that this summer was really anomalous, and there were many, many more blooms of the species. Now we can start accessing what are the possible causes that lead to the formation of these blooms here in Rio. So people are helping us a lot, and also scientists from different institutions. So I tried to create a kind of a network here on WhatsApp because it was the fastest way. And a lot of these people from different institutes got samples for us and also analyzed samples, analyzed pigments, phytoplankton, nutrients. So it was super useful. And we are now trying to organize this thing to monitor these harmful algal blooms here in Rio more systematically. So that's it. Thank you.
Thank you very much, Priscilla. This is a great presentation. It's now the turn of our third presentation. Our third speaker, Luis Paulo Assad, as Priscilla, is a professor of oceanography at the Federal University of Rio de Janeiro, Brazil. Luis Paulo works with oceanographic models and marine dynamics. And during the Rio Olympics, he developed together with sailors a predictive model of winds and current for the Guanabara Bay. Recording in progress. Luis, this floor is yours. Is there something wrong with this connection?
Uh-oh.
Yeah.
There you go.
Connecting.
Have to put in presenter mode.
He's muted.
Luis, there you go.
Sorry, I'm trying to share my screen here.
Yeah, you shared right. It was correct. You just had to put on presenter mode. There you go.
It's okay?
That's perfect. Thank you.
Okay, let's go. First of all, good morning here from Brazil. So the main idea of my presentation is to show some challenges that you have here in Brazil to use traditional observation platforms and try to show some possible solutions, mainly to work in urban coastal areas here in Brazil. Of course, one of the solutions is using low-cost sensors. So to talk about this, I will use an experience, a research project that we have here in a bay, just my side here at the University, Guanabara Bay here in Rio de Janeiro, during the years before the Olympic Games from Rio 2016. The name of this project was Nautical Strategy Project, and the main purpose, we were people from the Brazilian Olympic Committee just came to us and asked if it was possible for us to develop an oceanographic and a meteorological forecast system inside Guanabara Bay. And why Guanabara Bay? Because Guanabara Bay was the place where the sailing courses occurs. So like any other forecast system, we have this 4 modules, okay? We have a regional operational atmospheric model, a regional ocean model, a meteorological and oceanographic data acquisition system that is very important to evaluate the results that were produced by our forecast system, and a web platform. So here are some figures showing the circulations inside the Guanabara Bay and the winds over the area of Guanabara Bay. And these are some sensors that we use, traditional sensors that we use in our data acquisition system. So we have current profilers, we have weather stations, we have used some thermometers, submarine thermometers, and use some portable weather stations also too. And at the end, we produce also a web platform where we can share, where we could share some results to the coaches of the teams, of the sailing teams, and also for the athletes. So the real importance to acquire data for an operational forecast system is, of course, to evaluate if you are being able to represent well the present dynamics of the ocean atmosphere to proceed with good forecasts. So only to give a brief context where we are here in Brazil, Guanabara Bay is in Rio de Janeiro, of course, and this is the region of Guanabara Bay. So we have a small entry between the bay and the ocean, and then it opens, so we have this kind of geography. And these areas that you are seeing was the race courses that we have during the Olympic Games. And basically the dynamics of the bay works with tides, are forced with tides and winds. So we have a semi-diurnal tide, and as we see in this figure, we have a strong space distribution is very different in different areas of the bay. The red arrows are marked the flow during one situation that the water is going out of the bay, and the blue arrows mark the waters going inside the bay. So we have a very heterogeneity distribution of surface currents. So it's very important to map these currents in different areas of the bay. So this is another situation in another area, in another race course. As you see, we have a lot of difference of the currents. And talking about the wind circulation, we have a lot of orography effects related with the wind pattern inside the bay. So it's very important also to have a lot of measures inside the bay in order to have information that to be good, to have a very good appliance related to the sailing teams. So, but this is how the structure of the data acquisition system that we use during Olympic Games. So we have this ADCP, electromechanic submarine cable, electronic box that deals with the telemetry and the data acquisition. We have a weather station linked with this structure. So we produce it during the Olympic Games, real-time time series plots, okay? In this point, just over this island, just at the entry of the bay. So we could acquire sea surface water column velocity profile, we acquire wave data also too, and wind field also too. All of this information are using to evaluate our forecast system. But as you see, you have only one point inside the bay to measure, because it's very expensive to use these traditional observation platforms. That's why using low cost is very important for us. And that's why it's very important to integrate the community use of the bay to do this, to help us to acquire this data. So we're going to talk about some challenges and some problems that we face inside Guanabara Bay. This is our first weather station. We have 2 weather stations because, as I will show after, 2 of them was stolen. And we have some extreme events that we have also all of the time. We go to the island and to proceed with the maintenance because of these extreme events. As you see, the access of this island is very difficult. And this is another problem that we have. Is not, I know that it's not only a privilege of Brazilian waters. We have this in the whole world. Okay, the vandalism is very strong. And we have our electromechanic cable cut it. So, as a concluding remark, I only like to say that, of course, for a forecast system inside the coastal bay, we need to improve. We have more observations. The other important thing is we need to include other observation efforts as projects in Costa that have in our region. But of course, the use of low-cost Arduino weather station oceanographic sensors, together with opportunity vessels as fishers, urban transport inside Guanabara Bay, people from sports, the surf community also, as Bob said, it's very important also to have a very strong surf community here in Rio de Janeiro. It's very important also too, because we can, of course, increase the points that we acquire data and produce, for example, fields of sea surface temperature that will be assimilated in our forecast models. And only to show you that today we have a project that deals with operational oceanography inside Guanabara Bay that called bahiadigital.com, and you can go there and see some operational forecasts for atmosphere and oceanography, ocean also too. Thanks. Sorry about the time.
Don't worry. Thank you very much for your presentation. It's now time for last speaker. Our last speaker today is Andrew David Taylor. Andrew is currently the CEO of Blackbird Biologics Science and Environmental Advisors. His works are at the intersection of science, conservation, and the open source technology movement. Andrew runs several education and outreach initiatives, and through Oceanography for Everyone program and website, he builds open source CTDs, Niskin bottles, and other underwater sampling systems. Andrew, I hand over to you.
All right, well, thank you very much and good morning. Can everyone see this? Yes. So access to the tools of marine science is, oh, sorry, I gotta move something, there we go. Access to the tools of science is not equitable, and nowhere is this inequality of access more pronounced than in the ocean sciences, where all but a few entities have the capital to mount major oceanographic research campaigns. I come from the world of deep sea ecology, where budgets can quickly climb into the tens of millions of dollars, but even small scale coastal research can be stymied by the need for vessels, equipment, instruments, access to which is often controlled by research institutions. And as the need to understand the dramatic changes happening both at the surface and beneath the waves accelerates, barriers to access that precludes the participation of the full breadth of ocean stakeholders erodes our potential to understand, anticipate, and mitigate those changes. One of the missions of my post-academic career has been to make the tools of ocean science more accessible to more people. I believe that the ocean belongs to everyone and that the tools to study the ocean should be available to anyone with the curiosity and motivation to pursue that inquiry. And chief among those tools is the workhorse of oceanography, the CTD. So just in case anyone is unfamiliar, a CTD is a device that measures salinity, temperature, and depth. It can be used to profile a water column, affixed to an instrument to other instruments to correlate observations to water conditions, or deployed as a fixed mooring for long-term monitoring. Almost all marine scientific research includes a CTD cast, but commercial CTDs are expensive, and this creates a barrier to access for many of the people most imminently affected by our changing oceans. The OpenCTD is a low-cost open source alternative to commercial CTDs designed intentionally for budget-restricted scientists, educators, and practitioners working in nearshore coastal environments where entire research projects can be conducted for less than the cost of a single commercial CTD. The sensor quality on the OpenCTD is acceptable for the vast majority of ecology and conservation studies, though you probably won't want to use one if you're doing chemical or physical oceanography, and it operates to a depth of 140 meters. An OpenCTD can be built for about $350 US in parts and another $200 in tools and consumables. So I began developing the OpenCTD during my journey through the postdocalypse, looking for inexpensive ways to continue to conduct my own marine research while bouncing between short-term academic appointments. And because I'm not an engineer, the early years of OpenCTD development was a steep learning curve as I partnered with members of the nascent maker community to create increasingly more sophisticated instruments. In the 8 years since the project began, the OpenCTD family has grown from a core team of marine ecologists to a distributed community of scientists, engineers, makers, and conservation practitioners around the world. And throughout this entire development cycle, the core mission has always been to produce an instrument which could be built and understood by any user. We didn't want to create another data black box. We wanted to create something that would be just as at home in a high school classroom as in a top-tier research institution. So the brain of an OpenCTD is an Arduino microcontroller, a commonly available baby computer that can control a suite of sensors using a relatively approachable coding language. Arduinos are used in classrooms around the world as an introduction to coding and hardware development. And the Arduino talks to a real-time clock, which timestamps all the data, as well as an SD card reader where all the data is logged. All these components, when combined with a commercial chip to interpret salinity and a 3.7 volt lithium polymer battery, form the control unit. The control unit then interfaces with a sensor package that includes a battery of 3 temperature sensors, an absolute pressure sensor, which provides depth, and a graphite probe, which measures conductivity, which is then translated to salinity. Everything is housed within a very boring PVC pipe, and the sensors are fully potted in epoxy, and the open end is capped with an off-the-shelf pressure cap that the plumbers use to test pipe work, but that we've found to hold air down to 140 meters for a fraction of the cost of any engineered solution. With a custom circuit board that we designed and released under an open source license, someone with no prior experience in electronics, soldering, coding, or fabricating can build, calibrate, and deploy an OpenCTD over a long weekend. And that design process really highlights the core principles of the OpenCTD program. We want our device to be as inexpensive as possible while still producing high quality data. We want everything we possibly can to be released under an open source license so that anyone can take the base OpenCTD and expand, iterate, and adapt it to their needs. And we want the materials we use to be as accessible as possible so that people who want to build a CTD can find the parts they need in their local hardware stores and from major online retailers. We've also adopted a values agnostic approach to implementation. And by that, I mean that I don't believe that technology is in itself a panacea, but rather that carefully designed conservation technology programs can help fill the gap between the discovery of emerging problems and the will to solve those problems at a policy level. So I focus on conservation technology that promotes ownership of both data and the tools to collect that data within communities in a stakeholder up implementation model. And this means that rather than taking a top-down approach to delivering technological fixes to the problems facing our oceans, I prefer to work with communities to develop solutions that reflect and respect their specific needs and values. This often means that my goals are misaligned with kind of the dominant paradigm, especially in the US, of imported magic, where technology developers want to deliver one-size-fits-all solutions to local and regional problems. Imported magic, incidentally, is the technology sibling of parachute science. So anyone can build their own CTD, but the major way that we've kept this program funded is through hosting training workshops to teach students at many levels how to build their own instruments. Over the last few years, I've hosted CTD building workshops local to me in Maryland with marine educators at Stellwagen Bake National Marine Sanctuary and remotely with middle and high school students in Homer, Alaska. And for students, the process of building an open CTD offers an introduction to coding, 3D printing, hardware prototyping, electronics, and can provide a practical foundation for courses in earth science and marine or environmental science. I do want to introduce you to one other project, which is currently ongoing. This year, we sent open CTDs to naturalists working aboard commercial whale watch boats throughout New England to log and upload opportunistic pilot data while looking for whales. And you can track their progress and check out their data at communityoceanography.com. So there are far too many people to thank for this short time, but the Open CTD is and always will be a community effort. And I do want to acknowledge our key funders whose support kept the project alive long enough for us to reach this point. If you do want to check out the entire Open CTD project, I recommend you start with our GitHub repository, where we house all the documentation and source files. From there, you can find the full Open CTD construction and operation manual, which lays out the process of building an Open CTD in detail. Thank you very much.
Thank you so much, Andrew, and thank you for all the speakers for the great presentations. So the floor is open for questions. Yeah, anyone feel free to unmute yourself, raise your hand, and you can ask questions. Leslie, go on.
Hi, I'm the project director for the Deep Ocean Observing Strategy. So this question is for Andrew. I was just wondering, any plans to take that CTD down into the deep ocean?
We are working on it. I have a prototype version that can do 300 meters. And the real limitation on that is finding a pressure sensor that fits within our budget that can go that deep, and building a housing that can work that deep as well. But we are constantly trying to push it as deep as possible, while still respecting our need for it to be a low-cost solution.
Awesome, awesome. And let's keep talking, because we have other groups going cheap and deep with other sensors too.
Absolutely.
Jay, you have a question?
Thank you to the speakers. When I'm listening to Andrew and Bob and Priscilla, etc., I'm thinking that they want to propagate these capabilities out. But if you're going to propagate them, are you recording your methods that you use? Are you best practices? Are you able to circulate them and share them with the people you'd like to see adopt them? So what's your position on documenting the methods that you use?
I can jump in first. So we extensively document the entire process on a GitHub repository, which, full disclosure, GitHub is like the least accessible thing on the planet. It's absolutely inscrutable to anyone who hasn't sit and stared at a ton of code. But we do have a continuously updated construction and operation manual that goes through the entire process, talks about programs that have happened, and talks about all of the sort of downstream processing you need to do with data handling and calibration. So we try to document everything as much as possible, and we try to keep it as wide open as possible.
Thank you. Bob?
Yeah, I'll jump in as well. Yeah, first, I think Andrew's taking exactly the right approach, and the Open CTD project it's really great what you guys have been doing. Similarly with the certainly the mini SekiDisk, which we've been developing, it's been developed openly. I think that's a really important thing to do. Open source, all the files are available. We published a paper on it and made all the STL files available, and clear instructions on how to build them if you want. I think that's critically important. Getting on in terms of data collection methods, certainly with citizen science, teaching and demonstrating how to use these devices is absolutely critical, because one of the biggest criticisms with citizen science often is the quality of the data, and that's good teaching practices help to minimize data quality. I mean, other than that, I would say working with other people as well, and a more of a sort of multidisciplinary approach. So when I say others, I'm talking about, in my case, social scientists who can understand citizen motivations and all those kind of things that lead on to successful citizen projects.
Yeah, that's very exciting. I just would comment in final that there is an ocean best practices system and a repository that is totally open to everybody and easily searchable. I would encourage you, if you want, to contact me and I'll help you put your things into the ocean best practice repository. Thank you, guys.
Thank you.
Thank you.
Priscilla, you want to comment? You want to respond?
I was just going to say that in our case here in Rio, all we want is a little bit of the water. If we can reach the sample soon enough that the cells didn't eat each other inside the bottle, that's great. But we found that it was very hard to find a way to teach people how to fix a sample, for instance. So what we asked them is just to have a clean bottle, fill it with the water, try not to touch the water because it may be toxic, and just leave it in the shadow for us. And we go there and grab it. And there are some key observers already. There's a fisherman community. They work a lot of environmental tourism as well. And they are super engaged into collecting samples. And what we're trying to get now is funds to get kits, collecting kits to distribute to these key observers, but we didn't get these funds yet. And then to these people, then we can provide some training on how to collect the samples without contaminating and fixing samples and do these things. So this is a really starting project that we are hoping that it goes forward in the next years.
Thank you. Olamiyekan, I don't know if I'm pronouncing your name right, but I see you have your name raised. If you want to ask the question.
Yeah, thank you. Good afternoon to everyone. My name is John. I'm from Nigeria, and I'd just like to ask Andrew a quick question. Do you have plans? Like, what are the plans to extend some of these open CDT trainings to other places outside the US? Like, for example, other continents, maybe Africa. You know, where there's really a limit to the funds they get to to conduct ocean research. So like having trainings on open on the open CTD would definitely help progress ocean science research there. So I just like to know if you have plans to extend some of these trainings to places outside the US.
So I would absolutely love to extend our training as far as we can go. And if you are interested in running a workshop, we can talk and I'll look into finding funding opportunities for that. My big limit is I'm a one-person shop, and so I don't have tons of administrative capacity. So right now my focuses are in the US territories and small island developing states that have compacts of free association with the US, just because I don't currently have the administrative capacity to do a lot of international organizing, but I am very, very keen on extending this as far as it can go. One of the things that I've done in the past, not with OpenCTD yet, but with a different program I was involved in using small, low-cost robotics, was we do local community leader training workshops. And so I'll come out. We've done it in Papua New Guinea and in Saipan. I'll come out and run a training workshop to train local instructors on how to run the workshops, and then provide support that way, so that there's then in-country capacity to continue doing these kinds of building workshops that is independent of me and not dependent on having me figure out how to travel and get across the world.
Mm.
Thank you. We are open to more questions. I have one question, kind of a follow-up thing. I think Bob mentioned this, like the necessity to increase training. How does the scientific community sees data collected from citizen science? How is it perceived, and how can we, collectively like try to improve the perception. Like if it's well seen by the community, good, but if it's not, how can we work on this credibility in the scientific community?
Okay, I might jump in and start with that one if I may. Yeah, I mean, it surprised me at times how skeptical some scientists can be of citizen science observations. I mean, of course, it depends entirely on the nature of the observation, right, and how subjective that could be. So, for example, some of the temperature measurements that we collect on the surfboards, one could argue, I mean, of course, there can be issues around that, but it's a direct physical measurement of the ocean. Whereas, for instance, maybe some of the color measurements that we're collecting by citizens, that can vary depending on how people perceive color, right? I think ways to address that, I think as a community, citizen scientists need to really tackle this issue head on. And I think intercomparison exercises, so cases where we can compare the citizen observations. For example, I'm sure Andrew's been comparing the OpenCTD devices he's been developing with commercial off-the-shelf CTDs that cost a lot more money in order to really emphasize the quality of the data. We've did similar things with the smart fin, so we took it on a research cruise down the Atlantic, comparing the temperature measurements collected with other far more advanced devices. Similar with the color and the Secchi measurements as well, again comparing them with optical measurements that are collected thought to be collected with much higher accuracy. I mean, personally, it surprised me, actually. I mean, we collected a lot of these Secchi disk measurements and color measurements down the Atlantic as part of the Atlantic Meridional Transit cruises, and actually how accurate they relate to variables like chlorophyll, the concentration of phytoplankton in the water, compared to, you know, 20,000-pound radiometric equipment. So I'm deviating a bit, sorry. So yeah, comparisons with other existing technologies, and also that can be done at a larger scale as well, I think. So not just direct intercomparison exercises, but also bringing citizen observations into larger ocean observation networks, which can also be useful for quality control-based purposes. So I'll stop there.
I see some people with hands raised. Kana, like to ask a question?
So you actually were asked the question I was going to ask is, in the professional ocean science community, what's the level of acceptance? The big issue is probably going to be intercalibration. That's one issue. So has there been any thought given to that? Number one. Number two, have there been publications where OpenCTD and the Secchi disks have been used as a way to sort of inspire and get people going in this context?
Yeah, so we're working on a publication right now. We've done, throughout the entire development process, have been running comparisons against commercial devices, but we have been a little negligent in getting out scientific publications. One of the downsides of it being an all-volunteer operation, and none of us being, at least none of the core developers being academic scientists, is that when peer-reviewed publications aren't currency, they end up kind of at the bottom of your priority pile. But we are working on getting a publication out this year for the OpenCTD, and imminently doing some more robust data studies to publish those, to get them more integrated into the scientific literature.
From our perspective, I think an important point to first make is that, you know, the level of quality and sometimes skepticism among the scientific community does depend a lot on the variable you're measuring, right? So if you think about temperature, generally, maybe Andrew would disagree with me, but temperature is, in my opinion, it's a low-cost sensor that provides pretty accurate data. It's pretty stable, it's pretty robust. Whereas, you know, if you're trying to measure pH or maybe nutrient concentrations or something, and then you're probably likely to run into a lot more skepticism potentially for low-cost technology. I think the other thing to mention, which I didn't mention earlier with getting the scientific community on board, is the importance of quantifying uncertainties in the observations. So if we can do robust uncertain error propagation from right through from the sensor measurement through to the variable, then that can give at least us a little bit more confidence. So, okay, the citizen observation may be a bit more less accurate, but at least we can quantify that and use that when we use the data for scientific analysis. From our perspective, we have had quite a few publications out on both the SmartFin and on the mini SECI disk. I think there were some links in the slides that I showed earlier. So if you're interested in those, I'm happy to share the slides and share those links. And again, they've typically been involved around intercomparing the sensors with other data sources.
Yeah, just as a counterpoint to that as well, one of the things we've discovered throughout this project is that there are an awful lot of research labs with those little handheld CTDs that they're paying $6 grand from YSI that have not been calibrated in 10 years and are also wildly inaccurate. So there's sort of a little bit of a bootstrapping going on where just because they are using commercial CTDs doesn't necessarily mean their data is any higher quality than what we're producing, even without comparative calibrations.
So there's something in the chat from Bjorn talks about a potential field exercise. And I want to add to that, a bunch of us, João Vitorino is also online. We will be holding a field exercise next fall off of Portugal. And there will be a citizen science component. If any of you are willing and able or interested in joining or wanting us to make measurements with your devices, you're more than welcome.
Can you put that in the chat?
I will. And this is a US ONR funded project. So I'm pretty sure ONR would be very, very happy to take this on. So let me just give you my email and feel free to join, feel free to send me.
Thanks a lot, Mariana. In the chat, many people ask if we could stay in touch, share information and presentation. Could you further develop that?
Create a form. We can create a form after the meeting so we can all keep in touch. And I think it's also a way for everybody to know all the initiatives that are happening and continue the conversation. Yeah. Martin, I see you have a question.
Yes, thank you. Martin Krumpers, Ocean Ops at WMO. I just wanted to add to the data quality again. So I think it depends very much on the application, actually. For meteorological, for numerical weather prediction, for example, sea surface temperature, a very basic sensor can probably do the job where a physical or sonographer would probably not agree with the data quality. So that certainly plays a role here. And the other thing I wanted to say about data quality is if you have the choice between, well, low quality data or no data at all, well, you probably better take the low quality data, at least it is something. And we saw some graphs earlier today about where the sailing yachts, for example, go. They help us to get data from the Southern Ocean where we have absolutely no other opportunity. So that also might be rational to accept a lower data quality to have at least some data. Thank you.
Have a few more minutes for one more question. So yeah, after the meeting, I can create a form and then send to everybody. We can also, there was also some requests in the chat to post the video on YouTube. We usually post the video on the AtlantOS website, but you can also make it available on YouTube.
And would it be possible for us to get a copy of the chat log, just because there's a bunch of messages flying and I'm certain I've missed several.
Yes, for sure can send that.
Was that the last question? Or do we have one more?
I don't see questions. I see a lot of comments of like projects and willing to be engaged. People want to be engaged in the different projects that are already presented.
So maybe it's time to start the networking event. People.
You want to say something, Jay?
Yeah, Lucy mentioned something about a task team and low-cost sensors. Maybe, Lucy, you could elaborate that of what you're doing or what the purpose is.
Oh, yes, I could, but I'm sure Jetan or Tommy, which are there today, could further develop that as well. Tommy, Jetan, do you want to speak about that? No, they're being shy. So in the framework of the OBPS, the Ocean Best Practice System, we try to develop a network of best practices dedicated to coastal observation for under-resourced countries. So this started in January this year and will last for 18 months. And after some research on the literature, now we are trying to build a network. So we'll run some workshops, one next month within the OBPS workshop in October, and other events mainly in Africa. So we have a website, I can share the information, and we'll be really happy to share information about low-cost technology dedicated to coastal observation.
Awesome. Thank you all for joining. I think we're reaching the top of the hour. Thank you all the speakers for the amazing presentation. I really like to see all the engagement in the chat. It seems that people are very excited about the topic and for sure would like to know more about the project. So we will follow up with a form to continue the conversation. There is an opportunity to stay right now after the Ocean Hour. So the Ocean Hour is 1 hour. We're going to stop the recording now. But there is also an opportunity to just continue the conversation. There is this software called WonderMe. So it's just an opportunity if you guys want to stay and just continue chatting, or we can also just stay here also in the Zoom. But I will stop the